There is a place on this earth that fewer human beings have visited than have walked on the moon. It sits beneath 11 kilometers of water, in a silence so complete and a darkness so total that it exists, for most of us, as something closer to an idea than a place. We have sent machines there. We have measured it. We have named it. And still, after decades of looking, the honest answer to what happens at the bottom of the Mariana Trench is not fully known. That is not a failure. It is simply what depth does. It resists us quietly, and it has been doing so for a very long time. Most of us have looked up. We have stood on the ground at night and watched the sky open above us, and even if we did not know the names of the stars or the distances between them, we understood in some quiet and wordless way that what we were seeing was vast. Height is something we carry with us naturally. We look up at mountains and feel something shift inside. We stand at the edge of a cliff and feel the air pull at us. The sky has always been present, always visible, always part of the way we understand the world around us. It asks nothing of us but attention, and most of us have given it that, freely, without thinking, for our entire lives. Depth is not like that. Depth asks us to imagine something we have almost never seen, something our bodies have almost never known, and something that exists in a direction most of us spend very little of our lives facing. We do not look down the way we look up. The ground beneath us is solid, closed, final. It does not invite. And so the ocean, which covers more of this planet than anything else, which is older and deeper and stranger than almost any other feature of the earth, remains for most people a surface. A blue expanse seen from above. A horizon. Something looked at, not entered. This is worth sitting with for a moment because it means that the most significant portion of our own world, the part that holds the most water, the most pressure, the most silence, the most time, is a place we have barely begun to understand. Not because we lack the curiosity, not because the science is absent, but because the nature of depth itself makes it difficult to hold in the mind. We were not built for it. Our senses did not evolve to read it. Light does not travel there. Sound behaves in ways that feel wrong to us, and the distances involved, not the horizontal distances we are used to measuring across land, but the vertical ones, the ones that go straight down, are difficult to feel as real even when someone tells us the number. 11 kilometers. That is how deep the deepest point in the Mariana Trench reaches. If you wrote that number on a piece of paper and stared at it, it would not feel like anything in particular. It is only when you begin to compare it to things you already know that it starts to take shape. If you placed Mount Everest, the tallest mountain on the surface of the Earth, at the bottom of the Challenger Deep, the deepest part of the Mariana Trench, the peak of Everest would still be more than a kilometer beneath the surface of the water. It would not break the surface. It would not even come close. That single fact, quietly considered, begins to open something. It begins to suggest that depth, real depth, is not just a bigger version of what we already understand. It is a different kind of space entirely. The ocean has been called an inverted world, and in many ways this is accurate. On land, we move across surfaces. We travel horizontally. We look out across distances and navigate them with roads and paths and landmarks. The ocean, in contrast, is a world that opens downward. Its true geography is not its coastlines or its waves, but the vast vertical space that exists below them. There are mountain ranges on the ocean floor that rival anything on land. There are trenches and canyons and plains of sediment that stretch for hundreds of kilometers in perfect stillness. There are ecosystems that have never seen the sun, that have never will, that have been functioning in total darkness for longer than human civilization has existed, and almost none of it has been seen. This is the strange and quiet fact at the center of what the Mariana Trench represents. It is not simply a deep place. It is a deep place on a planet we have spent centuries believing we understood. We have mapped its continents. We have named its rivers and its mountains. We have walked across most of its land. And yet, if you were to take everything the ocean floor holds, every ridge, every basin, every trench, every slow and silent process happening in the dark, and place it on a map with the same resolution we use for the land, most of it would still be blank. The ocean floor is less well mapped than the surface of Mars. There is something in that comparison worth holding. Mars is another world entirely, tens of millions of kilometers away at its closest, and we have spent enormous effort and resources understanding it. The Mariana Trench is here. It is beneath us, in a sense. It belongs to the same planet we were born on, the same planet our ancestors walked and lived and wandered on for hundreds of thousands of years, and it remains, in a very real way, unknown. Not in the way that a problem remains unsolved, in the way that a landscape remains unvisited, in the way that silence remains unbroken. It is not waiting for us to arrive. It has simply been there, continuing without us for a very long time. To begin to understand what that place actually is, what it feels like as a condition of the Earth, what it holds, what it does, and what it quietly refuses to reveal, you have to start not with the bottom, but with the descent. You have to start with the surface, and with the slow, patient way that everything familiar begins, one layer at a time, to disappear. The Mariana Trench is not a single crack in the ocean floor. It is a long, curved system of trenches, a crescent-shaped groove that stretches across the western Pacific for nearly 2,000 kilometers, running roughly parallel to the Mariana Islands, which sit to its east. If you were to look at it from above, from the kind of altitude where coastlines begin to lose their detail and the ocean becomes a single unbroken color, you would not see it at all. It is far too deep, far too narrow in proportion to its length, and far too small against the vast canvas of the Pacific to register as anything other than a line, a crease, something you might overlook entirely, the way you might overlook a thin river when you are looking at a continent. And yet this crease is, in a very precise sense, the lowest place on the surface of the Earth. Not the lowest place in the ocean, the lowest place on the entire planet, if you measure from sea level downward. The point at the bottom of this trench, the place called Challenger Deep, sits at a depth of approximately 11,034 meters below the surface of the water. That number has been measured more than once with different instruments across different years, and each time it comes back close to the same value. Close, but not exactly the same, because at that depth, even the act of measuring becomes complicated. The pressure distorts instruments. The water itself behaves differently than it does closer to the surface. Getting a precise number from that place is not a simple task, and the small variations in the measurements are themselves a quiet reminder of how difficult this place is to know. Challenger Deep is not the only deep part of the Mariana Trench, but it is the deepest, and it is the part that has drawn the most attention. It is a basin within the trench, a further indentation in an already indented floor, and its shape is not a clean, symmetrical bowl. It is irregular. It has ridges and slopes and areas where the floor levels out before dropping again. The geometry of it is slow and uneven, the kind of landscape that does not resolve into a clear picture the way a mountain does when you look at it from a distance. It is a place that resists easy visualization, and this, in its own small way, is part of what makes it so difficult to hold in the mind. The Pacific Ocean, where the Mariana Trench sits, is the largest body of water on Earth. It covers more area than all the land on the planet combined. It is so large that when you look at a globe and find it, it seems to take up the entire front of the world, a blue expanse so wide that the continents on either side of it, Asia to the west, the Americas to the east, feel like edges, like borders framing something too large to look at directly. The Mariana Trench is a small feature within this vastness. It is a narrow wound in the floor of the largest ocean, running along the edge of a tectonic plate, shaped by forces that have been acting on it for tens of millions of years. Its scale, relative to the ocean that holds it, is modest, but its depth, relative to everything else on the surface of this planet, is not modest at all. To feel the shape of Challenger Deep as it actually is, it helps to think of it not as a hole, but as a valley of extraordinary depth, cut into the floor of the ocean over an immense span of time, with walls that slope downward gradually in some places and more steeply in others. The walls of Challenger Deep are not vertical. They are not cliff faces dropping into void. They are inclines, long and slow in places, and the floor at the bottom is not a single flat point, but a stretch of sediment that extends for several kilometers before the walls begin to rise again. It is a place with a floor, a place you could, in theory, stand on, if standing were possible there. The idea of that and of a floor of a ground at the very bottom of the world is one of the quieter and stranger things about the Mariana Trench. It is not empty space. It is a surface. It has texture and material and a kind of geography even at the deepest point on Earth. The sediment at the bottom of Challenger Deep is very fine. It has been accumulating there for a very long time. Not years, but thousands of years. Layers of tiny particles drifting down through the water column with a slowness that is difficult to imagine. Each layer is thin. Each one represents a long stretch of time in which very little changed at that depth. The sediment is a record, in a sense, though reading it requires patience and precision that goes well beyond what a single visit to the trench can provide. It holds information about the ocean, about the climate, about the chemistry of the water above it, but that information is locked in a way that releases itself only slowly, only under careful examination, and only partially. The walls of the trench, where they have been observed, are not bare rock. They are covered in layers of material, sediment, mineral deposits, biological residue, that have been building up over geological timescales. The place does not look empty. It looks layered. It looks old. It looks like somewhere that has been accumulating quietly in darkness for longer than most of us can comfortably hold in mind. And the water above it, 11 kilometers of it, presses down on all of this with a weight that transforms everything about how the place exists, how things move there, how sound travels, how life, where it exists at all, manages to persist. To understand what that weight actually means, what it does to water, to rock, to anything that enters that space, you have to descend a little further into the science of pressure itself and into what happens to the world as the surface falls away. There have been very few people who have actually been there. This is one of the quieter facts about the Mariana Trench, and it is worth pausing on, because we live in an age when almost anywhere on the surface of this planet can be reached, photographed, visited, and documented within days. We have been to the poles. We have crossed every ocean by surface. We have walked into deserts and climbed into the atmospheres of mountains so thin that breathing becomes a slow and careful act. And yet the bottom of the ocean, the deepest part of it, has been visited by fewer people than have walked on the moon. The number is small enough to list. The number is small enough that each visit carries a weight of its own, a quiet significance that comes not from glory or spectacle, but from the simple, patient difficulty of going there at all. The first time a human being reached the bottom of Challenger Deep was in 1960. Two men descended in a vessel called the Trieste, a bathyscaphe, a kind of submersible designed not to move quickly or gracefully through the water, but simply to go down. It was a heavy, slow machine, built for depth rather than speed, and the descent took nearly 5 hours. Jacques Picard and Don Walsh sat inside a small observation sphere at the bottom of the craft, and looked out through a window into a darkness so complete that their floodlights illuminated only a small circle of seafloor in front of them. They stayed at the bottom for less than 20 minutes. They saw sediment, they saw the faint disturbance of their own arrival, and then they began the long, slow journey back up. The entire experience, from start to finish, was quiet. There was no dramatic discovery. There was no moment of revelation. There was simply the fact that they had gone, and that the bottom was there, and that it was real. For a long time after that, no one went back, not because the interest disappeared, but because the technology required to reach that depth safely was extraordinarily difficult to develop, and the cost and complexity of doing so placed it far beyond the reach of most institutions. The Mariana Trench continued to be studied from above, through sonar, through the analysis of water samples, through instruments lowered on cables, but the idea of a person actually descending to the bottom again did not become real until decades later. It is a curious thing when you consider it. We put human beings on the moon within a decade of the first orbital flight. We built space stations and kept people living in them for months at a time. And the deepest point on our own planet remained for 50 years, a place only 2 people had ever seen with their own eyes. The next significant descent came in 2012, when the filmmaker James Cameron made a solo dive to Challenger Deep in a submersible called the Deep Sea Challenger. Cameron spent several hours at the bottom, collecting samples and filming footage, and his visit produced some of the clearest images of the trench floor that had existed up to that point. But even his images, taken with equipment far more advanced than anything available in 1960, could only show a small portion of what was there. The bottom of Challenger Deep is not a single point. It is a landscape spread across kilometers, and a single submersible, no matter how well equipped, can only illuminate a fraction of it in a single visit. The rest remains as it has always been, unseen. There is something in the way these descents have happened that is worth noticing. They have not been rushed. They have not come in rapid succession, one after another, each building on the last in a steady progression of understanding. They have been spaced apart by years, by decades, by long stretches of time in which the trench simply continued to exist without being looked at directly. The history of human visits to Challenger Deep reads less like a campaign and more like a series of quiet, isolated moments, each one separated from the others by long silences, each one brief, each one offering only a small and partial view of what is actually down there. It is a history of looking, rather than a history of knowing. This is partly a function of the technology. Building a vessel that can withstand the pressure at 11 kilometers of depth is not a simple engineering problem. The hull must resist forces that would crush most materials. The systems inside must function in conditions of near-total cold and absolute darkness. Every component must be tested and retested, because a failure at that depth is not something that can be corrected quickly or easily. The machines that go to the bottom of the Mariana Trench are among the most carefully designed objects human beings have ever built, and even they spend most of their time at the surface, waiting, being maintained, being prepared for descents that may happen only a few times in their operational lives. And so the trench has been visited, but it has not been explored in any sustained or comprehensive way. The portion of Challenger Deep that has been directly observed by human eyes or by cameras carried by human beings remains remarkably small. What we know about the place, about its ecology, its chemistry, its geology, the processes that shape it, comes largely from a distance, from instruments, from water samples, from sonar readings that paint a picture of the seafloor in sound rather than in light. The knowledge we have is real, and it is growing. But it is knowledge built on inference and measurement rather than on the kind of direct, prolonged observation that we take for granted when we study almost any other place on Earth. There is a patience in this that feels appropriate to the place itself. The Mariana Trench has not changed meaningfully in the time it has taken us to begin understanding it. It is not going anywhere. It is not shifting or eroding or disappearing. It is simply there at the bottom of the Pacific, waiting in a silence that does not feel like waiting at all. And the slow, careful way in which we have approached it feels, in retrospect, less like a limitation and more like a kind of listening, the kind that takes a long time and that does not rush toward an answer, because the answer, if it comes at all, will come in its own time. And before any of that can be fully appreciated, it helps to understand what happens to the world itself as you leave the surface behind. Light does not disappear all at once. This is something that is easy to assume, if you have never thought about it carefully, that there is a surface and beneath it there is brightness, and then at some point the brightness stops and the darkness begins, like a line drawn across the water. But that is not how it works. The transition from light to dark in the ocean is a slow and continuous process, a gradual dimming that takes place over hundreds of meters, and it happens in a way that feels less like a boundary and more like a fading. The kind of fading that is almost imperceptible while it is happening, and that you only notice when you look back and realize how far it has come. When sunlight enters the ocean, it does not travel in a straight and undiminished line the way it does through air. Water absorbs it. It absorbs different wavelengths at different rates, and this means that as you descend, the quality of the light changes before its quantity does. Red disappears first. It is absorbed within the first few meters, quietly and completely, so that even at a modest depth, the world beneath the surface has already lost one of its colors. Then orange goes, then yellow. The light becomes blue, and then a deeper blue, and then a blue so dark that it barely registers as color at all. It is not darkness yet. It is something in between, a twilight that has no name in most languages, a state of the world that exists only underwater and only within a narrow band of depth, and that most people, will never see. The zone where sunlight still reaches, where photosynthesis can still happen, where plants and algae can still convert light into energy, is called the photic zone, and it extends to roughly 200 meters below the surface. 200 meters sounds like a great deal if you are thinking about it in terms of human experience. It is taller than any building most people have ever stood beside. It is deep enough that the bottom of it is invisible from the top, and the top is invisible from the bottom. And yet, in the context of the Mariana Trench, 200 meters is almost nothing. It is less than 2% of the total depth. It is the thinnest skin on the surface of a place that goes on downward for a very long time after the light has gone. Below the photic zone, the ocean enters what is called the mesopelagic zone, the twilight zone. Here, some light still filters down, but it is faint, and it comes and goes with the time of day, and it is not enough to sustain photosynthesis. It is enough sometimes to see by if your eyes are adapted to it. Some creatures that live in this zone have evolved extraordinary sensitivity to light, capable of detecting single photons, single particles of brightness arriving from far above. They live in a world where light is rare and precious and unreliable, and they have built their entire existence around that scarcity. The twilight zone is a place of extraordinary biological activity, in fact, more so than many people realize. But even here, the light is already becoming a memory of what it was at the surface, and then it goes entirely. At around 1,000 meters, the last traces of sunlight vanish, and the ocean enters a darkness that is not like the darkness of a room at night, or the darkness of a cloudy sky, or the darkness of closing your eyes. It is a darkness that has no source, no edge, no variation. It is not the absence of light in the way we usually experience absence, as a lack, as something missing. It is a condition, a stable state. The water at 1,000 meters below the surface has not seen light in a very long time, not in the way that a basement has not seen light since the door was closed, in a deeper sense. The photons that reach this depth, on the rare occasions when conditions at the surface allow them to penetrate this far, are so few and so scattered that they do not form an image. They do not illuminate. They simply exist, briefly, and then they are absorbed and the darkness continues. This is the environment that extends for the remaining 10 kilometers of the descent to Challenger Deep. 10 kilometers of permanent, unbroken darkness, through which the water presses downward with increasing weight, and through which almost nothing moves quickly, and through which time passes in a way that feels, to the few instruments that have recorded it, very different from the way it passes at the surface. It is not that time slows down here. That is not how physics works, not at these scales. It is that the pace of everything that happens in this darkness is slow. The currents move slowly. The particles settle slowly. The processes that shape the seafloor unfold over thousands and millions of years. The darkness is not empty. It is full of things happening. But they are happening at a pace that the surface world, with its seasons and its storms and its cycles of day and night, would not recognize as activity at all. There is a quality to this kind of darkness that is difficult to convey in words, because we have almost no experience of it. We have seen dark rooms and dark nights and dark caves, but we have never been in a place where darkness is not an interruption, but a permanence, a place where it has been dark for longer than any human civilization has existed, and where it will continue to be dark long after we are gone. The darkness of the deep ocean is not waiting for the sun. It does not know about the sun. It is simply what the world is at that depth and has been and will be, and the creatures and the processes and the slow geological patience that exist within it have no relationship to light at all. They belong entirely to the dark, and the dark belongs entirely to them, and neither is incomplete because of the other. What fills that darkness, and what lives within it, and what the pressure of all that water does to the world below, are questions that open slowly, the way the darkness itself arrived. Not all at once, but in a quiet and continuous deepening. Pressure is something we rarely think about, because we are always inside it. The atmosphere presses down on us at every moment of every day, with a force we have never felt and never noticed, because our bodies evolved inside it, and it became, long ago, simply the condition of being alive on this planet. We do not feel the weight of the air above us. We do not sense it pressing against our skin or settling into our lungs. It is there always, and we have become so accustomed to it that it has become invisible. A background to everything, present but unregistered, the way silence is present in a quiet room until something interrupts it. The pressure at the bottom of the Mariana Trench is not like that. It is not background, it is not something that can be ignored or absorbed into the texture of daily existence. At the depth of Challenger Deep, the water above presses down with a force of approximately 1,000 atmospheres, 1,000 times the pressure that exists at the surface of the Earth, where we live and breathe and move through our days without noticing the weight of the air at all. 1,000 atmospheres is a number that is difficult to make feel real because we have no frame of reference for it. We have never experienced anything close to it. Our bodies, our machines, our buildings, our entire civilization exists within a narrow band of pressure that, compared to what exists at the bottom of the ocean, is almost nothing at all. To begin to understand what that pressure actually means, it helps to think about what happens to water itself as it is compressed. Water is often described as incompressible, and in most of the contexts we encounter it, this is true. If you squeeze a glass of water, it does not get smaller in any noticeable way. It holds its shape, it holds its volume. It behaves, for all practical purposes, as though it cannot be compressed at all. But this is only true at the pressures we are familiar with. At the pressures found at the bottom of the Mariana Trench, water does compress. It becomes very slightly denser than it is at the surface. The change is small, a few percent at most, but it is real, and it means that the water at 11 kilometers of depth is not quite the same substance as the water at the surface. It is heavier, it is tighter, it carries more energy per unit of volume, and it behaves in subtle ways differently. The ocean at the bottom of the Mariana Trench is not a uniform body of water. It is a layered system, and the deepest layers are under conditions that do not exist anywhere else on the surface of this planet. For anything solid that enters that depth, a piece of metal, a shell, a bone, a machine, the pressure does not press evenly and gently the way it does at the surface. It presses from every direction at once, and it presses with a force that most materials were not designed to withstand. A styrofoam cup, if you were to lower it on a cable to the bottom of Challenger Deep, would be crushed almost completely by the time it arrived. Not broken exactly, compressed, squeezed inward by the weight of the water above it, reduced to a fraction of its original size, its air pushed out, its structure flattened. Scientists have done this, have lowered styrofoam cups to great depths as a simple and vivid demonstration of what pressure does, and the results are striking in their quietness. The cup does not shatter, it does not explode, it simply becomes smaller and denser and harder, and when it is brought back to the surface it stays that way. The pressure has changed it permanently. It has rewritten the structure of the material, and no amount of time at the surface will undo what the depth did to it. This is what pressure does to things that are not built to withstand it. But the Mariana Trench is not a place where nothing has adapted to it. It is a place where certain things have adapted to it completely, where the pressure is not an obstacle to existence, but the very condition under which existence takes place. The creatures that live at the bottom of Challenger Deep do not experience the pressure as a force pressing against them from the outside. They experience it as the world. Their bodies are built around it, shaped by it, balanced by it. The water inside their cells is at the same pressure as the water outside. There is no differential. There is no crushing. There is simply an equilibrium maintained over evolutionary timescales between the organism and the environment it inhabits. To them, if they could be said to experience anything at all, the pressure is not heavy. It is normal. It is the only normal that has ever existed. This is one of the quieter and more profound things about deep-sea life, that the most extreme conditions on Earth by our standards are simply the ordinary conditions of someone else's existence. The pressure that would destroy a human body in an instant is, for certain organisms, the medium in which they live, the context in which they eat and move and reproduce and die. It is not something they endure. It is something they are. And this fact, when you sit with it, begins to shift the way you think about what extremes actually mean. They are not absolute. They are relative. What feels crushing to us feels like home to them, And the difference between the two is not a matter of strength or resilience, but of history, of the long, slow, patient process by which life finds its way into the conditions that are available to it, and then becomes those conditions and then forgets that there was ever anything else. The pressure at the bottom of the Mariana Trench will not change. It is as stable as anything on Earth. It has been there at roughly this magnitude for millions of years, and it will continue to be there, pressing down with the same quiet and unvarying force long after any of us have stopped wondering about it. It is not waiting to be overcome. It is not a barrier in any meaningful sense. It is simply the weight of the world settled at the bottom, and everything that exists there exists because of it, not in spite of it. And beneath that pressure, in that permanent darkness, the temperature settles into something very close to stillness. The deep ocean is cold. Not cold in the way that a winter morning is cold, or the way that a room feels cold when the heating has been off for a few hours. Those are colds that invite movement, that ask the body to respond, that carry with them an implicit suggestion that warmth is somewhere nearby and can be recovered if you seek it out. The cold at the bottom of the Mariana Trench is not like that. It is not an interruption. It is not a contrast to something warmer. It is simply the temperature of the place, and it has been the temperature of the place for a very long time, and nothing about it suggests that it will change. The water at the deepest parts of the ocean sits at roughly 1 to 4 degrees Celsius, just above freezing. Not frozen. The pressure at that depth actually lowers the freezing point of water slightly, so that it remains liquid even at temperatures that would turn surface water to ice. But it is very close to the boundary. It exists in a narrow thermal band, a quiet equilibrium between liquid and solid, and it stays there year after year, decade after decade, with very little variation. The temperature at the bottom of Challenger Deep does not have seasons. It does not have daily cycles. It does not warm and cool the way the surface does, responding to the sun and the air and the movement of weather above. It is simply cold, and it is consistently cold, and the consistency of it is one of the defining features of the place. This kind of cold is difficult to imagine from the surface because almost all of our experience of cold is temporary. We feel it, and then we leave it, or we warm up, or the season changes, or we put on another layer. Cold in our experience is something that passes. It is a condition that exists for a while and then is replaced by something else. At the bottom of the ocean, this is not true. The cold does not pass. It does not give way to warmth. It does not alternate with anything. It is the permanent state of the water, and everything that exists within it, every organism, every chemical process, every slow geological event, exists within that cold and has existed within it for longer than most things on the surface of the earth have existed at all. The effect of this sustained cold on the pace of life and process in the deep ocean is profound. Cold slows things down. This is true at a chemical level, at a biological level, at almost every level at which activity can be measured. Molecules move more slowly in cold water than in warm water. Chemical reactions proceed more slowly. Organisms metabolize more slowly. They eat less frequently. They grow more slowly. They reproduce more slowly. In the deep ocean, these slowdowns are not marginal. They are significant. Some creatures at great depth grow by fractions of a millimeter per year. Some processes that take days or weeks at the surface take months or years at depth. The entire tempo of existence in the deep ocean is quieter, slower, more drawn out than anything we encounter in the world we live in. This is not a hardship. It is not suffering or deprivation, in the way that we might experience slowness if our own lives were suddenly stretched to that pace. It is simply a different relationship to time. The organisms that live in the deep ocean do not experience their lives as slow. They experience their lives as they are. Their internal clocks, if they have them, are calibrated to the pace of the environment. A slow heartbeat is not a failing heartbeat. It is simply the heartbeat of a creature that has evolved in a place where speed serves no purpose and where the energy required to move quickly is energy that cannot be spared. There is a stillness in the deep ocean that goes beyond temperature, beyond the absence of light, beyond the weight of the water above. It is a stillness that comes from the convergence of all these conditions at once. No light means no photosynthesis at the surface to drive the rapid cycling of energy that characterizes shallow water. No warmth means no acceleration of the chemical and biological processes that create movement and change in warmer environments. No current of significant strength means that the water itself is not being stirred or turned over in any dramatic way. The result is an environment in which very little happens quickly, and in which the things that do happen unfold over timescales that make human patience seem hasty by comparison. The currents that do exist at the very bottom of the ocean are slow. They are called abyssal currents, and they move with a gentleness that is almost impossible to detect without careful instrumentation. They carry water from one part of the ocean floor to another, but they do so over years and decades, not hours or days. They are driven not by wind or by the motion of the surface, but by differences in temperature and salinity, by the slow, quiet physics of water finding its level, seeking its balance, moving as little as it needs to move in order to reach equilibrium. They are currents in the way that a glacier is movement, real, measurable, but so gradual that to watch them would require a patience that no single human life could accommodate. And so the deep ocean near Challenger Deep settles into something that feels, when you consider all of its conditions together, very close to rest. Not sleep exactly. There is activity here, there is life, there is process. But it is the kind of activity that does not announce itself. It does not disturb the stillness. It exists within it, quietly, the way breathing exists within silence, present, necessary, but not loud enough to break the quality of the quiet that surrounds it. The place is not empty. It is simply very, very calm, and it has been calm for a very long time, and the calm is not something imposed upon it from the outside, but something that belongs to it, intrinsically, the way darkness belongs to it, and pressure belongs to it, and cold belongs to it. They are all part of the same stillness, and the stillness is the place itself. Somewhere within that stillness, beneath 11 kilometers of dark and frozen water, the seafloor waits, covered in sediment that has been settling for millennia, and the texture of it, the quiet substance of the deepest ground on Earth, is something worth considering on its own. There is a floor. This is perhaps the most grounding and unexpected thing about the deepest point on Earth, that it is not an abyss in the way the word implies, not an endless void dropping away into nothing, but a surface, a ground, a place where the water ends and something solid begins, where particles have settled and accumulated and formed, over thousands and thousands of years, a layer of material so fine and so undisturbed that it holds, in its very texture, a record of everything that has drifted down to it from the world above. The seafloor at the bottom of Challenger Deep is covered in sediment. Not sand, the way a beach is covered in sand, with its coarse grains and its shifting and its responsiveness to wave and wind. This sediment is something finer, something quieter, a material composed of particles so small that they are, in many cases, invisible to the naked eye. They are fragments of rock ground down over geological time. They are the remains of organisms that lived and died in the water column far above, whose bodies sank slowly through the darkness and came to rest here, on the floor, adding themselves to the layer that was already there. They are mineral deposits, chemical precipitates, tiny pieces of the world that have been falling one by one for longer than human memory extends in any direction. The rate at which this sediment accumulates is extraordinarily slow. Scientists who have studied deep-sea sedimentation estimate that in places like Challenger Deep, the layer grows by something on the order of a few centimeters per 1,000 years, a few centimeters. The thickness of a finger added to the floor of the deepest place on Earth, over a span of time that encompasses the rise and fall of civilizations, the migration of entire populations, the invention and obsolescence of technologies that once seemed permanent. A few centimeters in 1,000 years, and yet the sediment is there, and it has been accumulating for far longer than 1,000 years, and the layer that now covers the floor of the trench is, in places, many meters thick. It is a testament to patience, on a scale that has no equivalent in human experience. The surface of this sediment, if you could see it, and very few instruments have ever been close enough to capture it clearly, would not look like anything dramatic. It would not look barren exactly, Though it would look sparse, it would look soft. It would look like something that yields easily to contact, that holds the impression of anything that touches it, that disturbs slowly and settles back slowly. When the submersibles that have visited Challenger Deep have disturbed the floor, even slightly, even with the gentle wash of water from their thrusters, the sediment has billowed upward in slow clouds, hanging in the water for a long time before coming back down. It does not snap back into place, it drifts, it settles. It returns to stillness at its own pace, which is a pace that has nothing to do with urgency, and everything to do with the weight and the cold, and the absolute absence of anything that might rush it. Beneath the surface layer of sediment, the floor is composed of older material, rock, mineral deposits, layers of compacted sediment from previous geological epochs. The structure of the seafloor is not uniform. It has been shaped by the same tectonic forces that created the trench itself, and those forces have left their mark in the form of ridges and slopes and areas where the rock is exposed, where the sediment has been scraped away by some geological event, and the harder material beneath it is visible. The floor of Challenger Deep is not a single flat plain. It is a landscape, quiet and slow and ancient, with a topography of its own, one that has been mapped to some degree by sonar, but that has been seen directly by very few eyes, human or otherwise. There is something about the idea of a floor at that depth that invites a kind of quiet contemplation. We spend most of our lives on floors, on ground, on surfaces, on the solid material of the earth that holds us up and gives us a place to stand and move and exist. The floor of Challenger Deep is in a sense the lowest floor on the planet, the most remote one, the one that is farthest from everything we know and everything we have built and everything we have ever touched. And yet, it is still a floor. It is still solid beneath the water. It still holds things. It still supports in its slow and patient way a thin and fragile layer of life that has found a way to exist upon it in the dark and the cold and the crushing weight of the water above. The floor does not care that it is the deepest. It does not know. It simply is, and it has been, and the things that rest upon it the way things rest upon any ground, quietly, without announcement, as though there were nowhere else to be. The sediment on this floor is not inert. It is not simply dead material piled up in the dark. It is a living substrate in many places, inhabited by organisms so small and so specialized that they are difficult to detect without the most careful and precise instruments. Bacteria thrive in it. Certain organisms burrow into it, moving through it with a slowness that matches the pace of everything else at that depth. The sediment is a community in a sense, a place where life and geology and chemistry are all happening at once, all interleaved, all proceeding at a pace that is slow enough to feel from the outside like stillness. But it is not stillness. It is activity of a kind, activity that does not disturb, activity that does not announce itself, activity that has been happening, quietly and continuously for a very long time, on the floor of a place that most of the world has never seen and will never see, and that continues in the dark, whether anyone is watching or not. What lives there? What has found a way to persist in that sediment, in that darkness, under that weight, is a question that opens slowly, and that leads, as most questions about the deep ocean eventually do, into territory where the known and the unknown begin to blur. Life at the very bottom of the ocean does not look the way most people imagine it. There is a tendency, when we think about deep-sea creatures, to think of the strange and the dramatic. The luminous fish with their vast teeth, the creatures with translucent bodies and long trailing tentacles, the organisms that produce their own light in the darkness, like small living stars. And those creatures do exist, many of them, in the layers of the ocean above the very deepest points. They are real and they are remarkable, and they have earned their place in the popular imagination of what life in the deep ocean means. But at the very bottom of Challenger Deep, in the sediment and the darkness and the crushing pressure of 11 kilometers of water, life takes a different form. It is quieter than that, it is smaller, it is slower, and in many ways it is more extraordinary, precisely because it is so easy to overlook. The organisms that have been found at the greatest depths of the Mariana Trench are, for the most part, not the kind of creatures that command attention. They are amphipods, small crustaceans, related to shrimp, that scuttle across the seafloor and through the sediment with a patience and a persistence that seems almost indifferent to the conditions around them. They are not large. They are not visually striking. They do not glow or flash or display any of the adaptations that make shallower deep-sea life so compelling to look at. They simply exist in the dark and the cold and the pressure, going about the quiet business of finding food and surviving, in a place where survival itself is a kind of quiet achievement. These amphipods feed on what falls. This is one of the central facts of life at the very bottom of the ocean, that almost everything that happens there is sustained not by energy produced on the seafloor itself, but by energy that originated at the surface and has been slowly, patiently sinking for a very long time. When organisms die in the upper layers of the ocean, their bodies do not simply disappear. They break down slowly as they fall, but some portion of them continues downward, through the darkness, through the layers of pressure and cold, until it reaches the floor. This material, called marine snow by scientists, because of the way it drifts downward in the water column, slowly, continuously, like a fall of very fine and very quiet flakes, is the food source for much of the life at depth. It is not abundant. It arrives in small quantities, irregularly, and the creatures that depend on it have evolved to be extraordinarily efficient in how they use it. The amphipods at the bottom of Challenger Deep have been observed, on the rare occasions when instruments have been close enough to detect them, gathering around any organic material that reaches the floor. They congregate. They feed. They do so with a speed that is, relative to the pace of everything else at that depth, surprisingly quick, as though the arrival of food is an event significant enough to break the general slowness of their existence, at least briefly. Scientists who have studied these creatures have used baited traps lowered to the floor on cables to attract and capture them. The traps have come back with hundreds of amphipods in them, drawn from the surrounding sediment by the scent of the bait drifting through the water. It was one of the first clear demonstrations that life at the very bottom of the Mariana Trench was not sparse or marginal, but present in numbers that surprised the researchers who found them. Beyond the amphipods, the sediment itself is teeming with microbial life, bacteria and archaea, single-celled organisms so small that they are invisible without magnification, that inhabit the particles of the sediment and the thin films of organic material that coat them. These microbes are not glamorous. They do not move in ways that can be seen. They do not produce light or display any behavior that would be recognizable as activity to an observer, but they are doing something essential. They are breaking down organic material. They are cycling nutrients. They are converting chemical compounds from one form to another, slowly, continuously, in a process that sustains the chemistry of the deep sea floor in ways that are only beginning to be understood. Without them, the sediment would not be what it is. The floor of Challenger Deep would be a dead place. Instead, because of them, it is alive, quietly, microscopically, persistently alive. There are also larger organisms found at great depth, though they become rarer and less well understood as the depth increases. Holothurians, sea cucumbers, have been observed moving across the seafloor of deep trenches, feeding on the sediment, extracting whatever organic material it contains. They move slowly. They are not conspicuous. They belong to the same quiet, patient community as the amphipods and the microbes, and they play their own role in the cycling of material on the deep seafloor. There are also certain species of fish that have been detected at extraordinary depths. The deepest confirmed fish species, a type of snailfish, was recorded at a depth of more than 7,000 meters, feeding on the amphipods and other small creatures that gather in the trenches. It is a pale, soft-bodied creature, with none of the armored or dramatic features that characterize fish in shallower water. It is built for pressure and for darkness, and it moves through both with a quiet ease that suggests it has never known anything else. What all of these organisms share is an existence that is defined not by spectacle, but by endurance. They live in conditions that would be lethal to almost any organism evolved at the surface. The pressure would crush them. The cold would stop their metabolism. The darkness would starve them of the energy that most life on Earth depends on, and yet they are there, and they have been there, and they have been adapting to those conditions for millions of years, long before any human being thought to look for them. Their presence at the bottom of the Mariana Trench is not an anomaly. It is not a surprise to the scientists who study it, though it remains in some quiet way a source of wonder. It is simply what life does. Given enough time and enough pressure and enough darkness, it finds a way, not dramatically, not loudly, but with a persistence that, when you consider the conditions it persists within, is one of the quietest and most remarkable things about this place. And the place itself, the conditions that shaped these creatures, the geology that created the trench and continues to act upon it, is a story that unfolds not over years or centuries, but over spans of time so large that they require a different kind of thinking entirely. There is a line in the study of the deep ocean between what has been seen and what has been concluded. It is not a sharp line. It does not fall in one place or at one moment. It is more like a gradual shift in the quality of the knowledge itself, a place where the statements scientists make about the Mariana Trench begin to change from descriptions of what has been directly observed to descriptions of what the available evidence suggests is likely true. And this shift happens earlier than most people would expect. It happens not at the edges of our understanding, but near its center. Much of what we believe we know about the deepest parts of the ocean is not based on looking. It is based on reasoning, on inference, on the careful and patient assembly of indirect evidence into a picture that feels coherent, even though large portions of it have never been confirmed by direct observation. This is not unusual in science. Many of the things we are most confident about, the interior of the Earth, the composition of distant stars, the history of the universe itself, are conclusions drawn from evidence that is not direct. We have never been to the center of the Earth. We have never touched the surface of the sun. We have never witnessed the beginning of the cosmos. And yet we know a great deal about all of these things, because the evidence we do have, the measurements, the calculations, the patterns, points consistently in certain directions, and because the models we build to explain that evidence are tested against new data again and again and hold up. Science does not always require presence. It does not always require sight. Sometimes it requires only patience and a willingness to listen to what the available information is saying, even when that information is incomplete. The Mariana Trench is a place where this kind of knowledge dominates. The amount of the trench floor that has been directly observed, by cameras, by instruments carried by submersibles, by any technology that has actually looked at the place, is, by any honest accounting, very small. Challenger Deep stretches for several kilometers, and the portions of it that have been filmed or photographed represent a tiny fraction of its total area. The rest has been mapped by sonar, by sending sound waves downward and reading the echoes that return. And sonar tells us a great deal about the shape of the seafloor, about its depth and its contours and its broad geography. But sonar does not tell us what the floor looks like. It does not tell us what color it is or what texture it has, or what is living on it at any given moment. It gives us a picture in sound, and that picture is valuable, but it is not the same as seeing. What we know about the chemistry of the water at the very bottom of the trench comes for the most part from samples, water collected at depth, brought to the surface, and analyzed in laboratories. These samples are extraordinarily valuable. Each one represents a tiny window into the conditions that exist at a particular depth, at a particular location, at a particular moment in time. But they are also, by their nature, limited. A sample taken from one spot does not necessarily represent what the water is doing a kilometer away. And the act of collecting the sample, of bringing it up through 11 kilometers of water, through changing pressures and changing temperatures, can alter its properties in ways that scientists must carefully account for. The water in a sample is not quite the same water that existed at the bottom. It has been changed by the journey. The knowledge we extract from it is real, but it is knowledge that has been filtered through a process, and that process leaves its marks. There are things about the Mariana Trench that scientists are very confident about, and things they are less confident about, and the difference between the two is not always obvious from the outside. The depth of Challenger Deep is well established, measured multiple times with multiple instruments, and confirmed to within a few meters. The temperature of the water at the bottom is well established. The pressure is well established. These are things that can be measured directly, repeatedly and consistently, and the measurements agree with each other. but the biological community at the bottom, the full picture of what lives there, how it interacts, what it depends on, how it responds to changes in the environment above, is far less well understood. We know some of the organisms that are present. We know, in broad terms, how they feed and how they survive. But the details, the relationships, the dynamics, the processes that are happening in the sediment on a daily or yearly basis are largely inferred, built up from the small number of observations that have been made and from what we know about similar environments at lesser depth. This is the honest condition of our knowledge about the Mariana Trench. It is partial. It is unevenly distributed. Some aspects of the place are well understood, and others are barely understood at all. And the boundary between the two does not always align with what feels important or central. We know the shape of the trench better than we know what is living in it. We know the pressure better than we know the ecology. We know the geology better than we know the biology. And in each case, the knowledge we do have is real and meaningful, but it coexists with a large and quiet space of uncertainty, a space that is not empty exactly, but that has not yet been filled with the kind of direct, patient observation that would allow us to say with confidence that we understand what is happening there. There is a temptation, when confronted with this kind of uncertainty, to treat it as a problem, as something that needs to be solved, as a gap that needs to be closed, as evidence of some failure or incompleteness in the way we have approached the study of the deep ocean. But this temptation is worth resisting because the uncertainty is not a failure. It is a natural consequence of the place itself, of its depth, its darkness, its resistance to observation, its quiet refusal to yield its secrets quickly or easily. The Mariana Trench does not owe us understanding. It does not exist to be known. It exists because the Earth made it, over millions of years, and it continues to exist whether we understand it or not, in the same way that it has always existed, patiently, silently, and with no particular interest in whether anyone is paying attention. What the place does offer, if you are willing to sit with it long enough, is not answers. It is a different kind of relationship to the question, one in which not knowing is not a discomfort, but a quietness, and the quietness itself becomes something worth staying with. Sound does not behave the way we think it does, or rather, it behaves exactly the way it does, but the way we experience it, in air, in the open spaces of our daily lives, is so specific, so narrow in its range, that we have come to assume it is the only way sound can exist. We hear voices and music and wind and rain, and we hear them in a particular way with a particular quality, and we take that quality for granted, the way we take so many things for granted that are simply the product of the medium we live in. Air is our medium. It is the substance through which sound travels to reach us, and it shapes the sound in ways we do not notice, because we have never heard sound travel through anything else. Water is different. Sound moves through water faster than it moves through air, significantly faster, in fact, roughly 4.5 times faster. This is not a small difference. It is a fundamental change in the way sound exists, and it means that the acoustic world of the ocean is not a quieter version of the acoustic world we know. It is a different world entirely. Sound in water does not spread and fade the way it does in air. It does not attenuate as quickly. It can travel enormous distances, hundreds, sometimes thousands of kilometers, before it loses enough energy to become inaudible. The ocean, in this sense, is not a silent place. It is a place in which sound persists, in which it carries, in which it moves with a reach and a patience that the air cannot match. And yet, to a human being placed at the bottom of Challenger Deep, if such a thing were possible, if a human being could somehow exist there without being destroyed by the pressure, the experience would not feel like sound. It would feel like silence, not because there is no sound at the depth of the trench, but because the sounds that exist there are not the kinds of sounds that human ears are built to hear. They are too low in frequency. They are too diffuse. They are spread across such vast distances and such long durations that they do not resolve into anything that a human listener would recognize as a sound event, as something with a beginning and a middle and an end, the way a voice or a footstep or a wave breaking on a shore has a beginning and a middle and an end. The sounds of the deep ocean are more like conditions than events. They are ongoing. They are ambient. They are the background hum of a world that is not in fact quiet, but that is quiet in all the ways that matter to us. There are sounds at depth that scientists have recorded and studied, sounds produced by geological activity, by the movement of water, by biological processes happening in the water column or on the seafloor. Some of these sounds are extraordinarily low in pitch, infrasound, below the range of human hearing entirely, and they travel through the ocean for thousands of kilometers, carrying information about their source across distances that would be impossible in air. The ocean has been described by some researchers as one of the noisiest environments on Earth when you measure sound across the full range of frequencies that water can carry. But almost none of that noise is audible to us. It exists in a register that our senses cannot access, and so it remains, for all practical purposes, invisible, a layer of the ocean's reality that is there and is real and is measurable. But that does not enter our experience at all. At the very bottom of the Mariana Trench, the sound environment is particularly sparse. The sources of sound that exist in shallower water, the biological activity, the movement of currents, the distant rumble of surface weather, are attenuated by the depth and the distance, and what reaches the floor of Challenger Deep is reduced to something very faint, very diffuse and very slow. The place is not perfectly silent. Perfect silence does not exist anywhere in the physical world, because there is always some vibration, some movement, some energy propagating through the medium. But it is close. It is as close to silence as anywhere on Earth gets, and the silence it offers is not the silence of an empty room or a quiet night, but something older and more complete. The silence of a place that has been undisturbed for a very long time, and that has no reason to be disturbed, and that simply continues in its quietness, without waiting for anything to change. There is a philosophical dimension to this, to the idea that the deepest place on Earth is also in some sense one of the quietest. Silence, in our experience, is usually a temporary condition. It is the space between sounds, the pause between events, the moment when the world stops making noise for a little while before it starts again. It is defined by what surrounds it. It is the absence of something. But the silence at the bottom of the ocean is not like that. It is not defined by what is missing. It is defined by what is present, by the density of the water, by the depth, by the cold, by the pressure, by all the conditions that conspire to make sound travel differently and life move slowly, and everything happen at a pace that does not produce the kind of noise that we would recognize. The silence is not an absence. It is a fullness. It is the sound of a world that is doing everything it does, but doing it in a way that does not reach us. This is one of the things that makes the deep ocean feel, to those who have spent time thinking about it, less like an empty place and more like a full one, a place that is happening continuously in registers and at paces that we cannot perceive. The silence we would experience there, if we could experience it, would not be the silence of nothing. It would be the silence of everything proceeding exactly as it always has, in the dark and the cold and the weight of the water, without any need for us to hear it, or to know about it, or to be present at all. The water itself, the medium through which all of this silence travels, and in which all of this quietness exists, is not a simple substance, and the way it moves at depth is shaped by forces that have been acting on it for far longer than human beings have been alive to wonder about them. The Mariana Trench was not always there. This is a fact that is easy to forget, because the trench feels, when you think about it, like something permanent, like something that has always existed, in the same place, in the same shape, doing the same quiet thing it is doing now. And in human terms, it has. It has been there for longer than human beings have existed, longer than most species on Earth have existed, longer than almost any frame of reference we have for measuring time. But in the terms that the Earth itself uses, in the slow, patient language of geology, the Mariana Trench is not ancient. It is, by geological standards, relatively young. It has been forming for tens of millions of years, and it is still forming, still deepening, still being shaped by the same forces that created it right now, at this moment, though the pace at which it is changing is so slow that no human instrument has ever detected it in real time. The force that created the Mariana Trench is called subduction, and it is one of the most fundamental and patient processes in the history of the Earth. Subduction is what happens when one tectonic plate, one of the enormous slabs of rock that make up the outer shell of the planet, moves toward another plate and slides beneath it. Not quickly, not violently in most cases, though it can produce earthquakes and volcanoes when it does so. But over millions and millions of years, one plate dips downward, descending beneath the other, disappearing into the deeper layers of the Earth in a process so gradual that it is invisible on any human timescale. It is the Earth rearranging itself, one plate at a time, in a way that has been happening continuously for billions of years. The Mariana Trench exists because the Pacific Plate, one of the largest tectonic plates on Earth, is subducting beneath the Philippine Sea Plate. The Pacific Plate is moving westward slowly, at a rate of a few centimeters per year, and as it encounters the Philippine Sea Plate, it bends downward, curving beneath it, and the place where it bends, the place where it tips from horizontal to sloping, where it begins its long descent into the mantle of the Earth, is where the trench forms. The trench is, in a sense, the crease, the fold, the place where one piece of the Earth's surface is being pulled beneath another, and the water above fills the space that the folding creates, and the result is the deepest groove on the surface of the planet. This process has not happened all at once. It has been happening continuously for somewhere in the range of 50 to 60 million years, a span of time that is difficult to hold in the mind without losing its meaning entirely. 50 million years ago, the Pacific and Philippine sea plates were in different positions than they are now. The trench, to the extent that it existed at all, was shallower, younger, still being carved by the slow and patient action of subduction. Over time, as the Pacific Plate continued to move and continued to bend, the trench deepened. It did not deepen quickly. It deepened by fractions of millimeters per year or perhaps less, over millions upon millions of years, accumulating depth the way the seafloor accumulates sediment, quietly, imperceptibly, in a process that only becomes visible when you look at it across timescales that no single human life can encompass. The walls of the trench are shaped by this same process. They are not smooth or uniform. They are the result of rock being bent and fractured and compressed over tens of millions of years, and the fractures and the ridges and the irregular slopes that characterize the walls of Challenger Deep are all records of that bending, geological memories, if you will, of the forces that have been acting on this part of the Earth for longer than most life on the planet has existed. The walls hold information about the history of the trench in their very structure, in the way the rock has been folded and broken and layered, and reading that information requires the same patient and indirect approach that characterizes so much of what we know about the deep ocean. You cannot simply look at the walls and understand them. You have to interpret them, slowly, over time, using the tools and the knowledge that geology has built up over centuries of careful study. Subduction is also the reason why the Mariana Trench is where it is, in the Western Pacific, near the edge of the Philippine Sea Plate, in a place that is not random, but is, in fact, one of the most tectonically active regions on Earth. The Western Pacific is a place where plates are converging, where the crust is being remade, where volcanoes are forming, and islands are rising, and the deep structure of the planet is closer to the surface than it is almost anywhere else. The Mariana Islands, which sit just to the east of the trench, are themselves the product of this activity. Volcanic islands, built up from the magma that is produced when the subducting Pacific Plate melts as it descends into the heat of the mantle. The trench and the islands are part of the same system. They are two expressions of the same geological process, one going down and one coming up, both shaped by the same slow and patient forces. There is something in this, in the idea that the deepest place on Earth and the islands that sit beside it are both products of the same movement, the same bending, the same millions of years of geological patience that invites a certain kind of reflection. The Earth is not a static thing. It is not a finished object sitting in space, unchanging. It is a process. It is something that is happening continuously at a pace that is invisible to us, but that is, when measured across the timescales, it actually operates on, remarkably steady and remarkably consistent. The trench is deepening right now. The plates are moving right now. The subduction that created Challenger Deep and that continues to shape it is not a past event. It is a present one. It is simply happening too slowly for us to see. The patience of the Earth, in this regard, is not a metaphor. It is a literal description of the timescales on which the planet operates, timescales on which human beings are, in a very real sense, too brief to witness anything, and on which the deep ocean continues to be made, quietly, whether we are watching or not. The machines that go to the bottom of the Mariana Trench are not like the machines we are used to thinking about. They are not fast. They are not sleek. They do not move through the water with any of the confidence or precision that we associate with modern technology, with spacecraft or aircraft, or the devices we carry in our pockets, which respond to us instantly and operate with a speed that has become, over the course of a few decades, indistinguishable from thought itself. The machines that descend to Challenger Deep are slow. They are heavy. They are built not for elegance but for endurance, not for speed but for survival. And the way they move through the water is less like flying and more like sinking, a controlled, deliberate, patient descent through 11 kilometers of increasing darkness and increasing pressure, guided by instruments and by the slow and careful calculations of the engineers and scientists who designed them. The earliest of these machines, the bathyscaphs of the mid-20th century, were crude by any modern standard, and they knew it. The Trieste, which carried Picard and Walsh to the bottom of Challenger Deep in 1960, was essentially a large steel sphere attached to a heavy ballast tank filled with liquid gasoline. The gasoline served as buoyancy. Lighter than water, it kept the craft from sinking too quickly, and when the crew wanted to descend, they released iron ballast weights, allowing the craft to drop slowly through the water column. The descent was not powered, it was gravitational. The Trieste did not fly downward. It fell gently, at a pace determined by the balance between its weight and its buoyancy, and it took nearly 5 hours to reach the bottom. There was no way to steer it with any precision. There was no way to stop and hover at a particular depth and look around. There was simply the descent, and then the brief time at the bottom, and then the ascent, which was achieved by releasing more ballast and allowing the craft to float back up, just as slowly as it had gone down. The technology has changed since then, but it has not changed as dramatically as one might expect. Modern submersibles, the kind that have visited Challenger Deep in more recent decades, are more sophisticated, more maneuverable, more capable of holding position and collecting data. They have cameras with high resolution. They have mechanical arms that can reach out and interact with the environment. They have sensors that can measure the chemistry of the water, the temperature, the pressure, the composition of the sediment. They are, by any reasonable measure, remarkable machines. And yet they are still fundamentally doing the same thing the Trieste did. They are going down. They are spending a limited amount of time at the bottom, and they are coming back up. The basic structure of the encounter with the deep, the slow descent, the brief visit, the slow return, has not changed in 60 years because the deep itself has not changed, and the constraints it imposes on anything that enters it remain the same. One of those constraints is power. At the depths of the Mariana Trench, there is no sunlight to generate energy, there is no wind, there is no current strong enough to be harnessed. The submersibles that descend there carry their own power with them, batteries in most cases, and those batteries have a finite life. They can sustain the craft for a certain number of hours before they are depleted, and once they are depleted, the craft must return to the surface. This means that every descent to Challenger Deep is, from the moment it begins, a countdown. Not an urgent countdown, not a countdown that produces anxiety or haste, but a quiet and steady one, a reminder that the time at the bottom is limited, and that the machine must use it as wisely as it can, because there will not be another opportunity for a very long time. The submersibles that have visited Challenger Deep have spent, in total, a surprisingly small amount of time at the bottom. Add up all the hours that all the machines have spent at the deepest point on Earth, across all the descents that have ever been made, and the number is modest. It is not days, it is hours, a few dozen hours, spread across decades, each one precious, each one representing an enormous investment of time and money and engineering effort. Every minute at the bottom of Challenger Deep has been earned, in a sense, by years of preparation and planning and the slow, careful development of the technology required to get there and to survive there long enough to learn something. And what the machines have learned in those hours has been valuable, but it has also been limited in the way that any brief visit to a large and complex place is limited. They have seen portions of the seafloor. They have collected samples. They have measured conditions at specific locations and specific times, but they have not seen the trench as a whole. They have not watched it over time, the way a scientist might watch a forest or a coral reef over months or years, building up a picture of how it changes and how its parts relate to each other. They have seen snapshots, moments, small windows into a place that is vast and slow and continuous, and that does not pause or repeat itself for the benefit of observers who can only be there briefly. There is a quietness to the way these machines operate that feels, in retrospect, appropriate to the place they are visiting. They do not rush. They cannot rush. The water resists rapid movement at that depth, and the instruments require time to collect meaningful data. And the scientists who design the missions know that patience is not just a virtue in this context, but a necessity. Our submersible descending to Challenger Deep moves through the water at a pace that a person walking could match, and it arrives at the bottom without fanfare, without drama, settling onto the sea floor the way a leaf settles onto still water, slowly, gently, disturbing as little as possible, because even the act of arriving is an interruption, and the scientists want to see the place as close to undisturbed as they can manage. The machines are not permanent. They are not a continuous presence at the bottom of the ocean. They come and they stay for a while, and they leave, and the trench continues as it was before they arrived, with no memory of their visit and no alteration that would be detectable by anything other than the most sensitive instruments. They are visitors in the truest sense, brief, quiet, and ultimately inconsequential to the place itself, which has been there and will continue to be there long after the last machine has returned to the surface and been dismantled and forgotten. What those machines have shown us in their brief and patient visits is not the whole of the Mariana Trench. It is a beginning, a first, slow, careful look at a place that will take a very long time to understand, if it can be understood at all. There is a version of the story of the Mariana Trench in which it is an anomaly, a single exceptional feature of the Earth, the deepest point among many, a curiosity at the extreme end of a spectrum, remarkable precisely because it is so far from everything else. And in one sense this is true. Challenger Deep is by definition the lowest place on the planet, and no other place on Earth shares that particular distinction. But in a deeper sense, the Mariana Trench is not an anomaly at all. It is not an outlier. It is not something that exists apart from the rest of the world, separate and singular, and unlike everything around it. It is instead one expression of something much larger, a place where the general condition of the deep ocean becomes visible in its most extreme form. The way the tip of an iceberg is a place where the iceberg becomes visible, even though the iceberg extends far below the surface, in the dark, where no one can see it. The deep ocean, not just the Mariana Trench, but the entirety of the ocean floor below a few hundred meters of depth, is one of the least understood environments on this planet. This is a fact that is stated often in popular science and in the scientific literature alike, and it is stated so often that it has begun to lose its force, to become a piece of received knowledge that is repeated without being fully felt. But it is worth feeling if you can, because it means something specific and significant about the relationship between human beings and the world they live on. It means that the majority of the Earth's surface, the part covered by water, which is the majority, remains in large measure a place we have looked at but have not entered, have measured but have not understood, have mapped in outline but have not explored in detail. The Mariana Trench is the deepest expression of this condition, but it is not the only one. It is simply the place where the condition is most stark. Consider what the ocean floor actually is, across its full extent. It is a landscape of extraordinary variety and complexity. There are mid-ocean ridges, mountain ranges that stretch for tens of thousands of kilometers across the floors of the world's oceans, longer than any mountain range on land, built up over millions of years, by the slow upwelling of magma from beneath the Earth's crust. There are abyssal plains, vast flat expanses of sediment that cover enormous areas of the ocean floor, so flat and so featureless that they have, in some places, barely changed in millions of years. There are hydrothermal vents, places where superheated water rises from deep within the Earth, carrying with it minerals and chemicals that sustain ecosystems entirely independent of sunlight, ecosystems that thrive in darkness and heat, and that challenge our understanding of what life requires in order to exist. There are submarine volcanoes, seamounts, underwater canyons, and geological formations that have no equivalent on land. And almost all of it, the vast majority of it, has been seen by no human eye. The maps we have of the ocean floor are, for the most part, built from sonar. They are pictures made of sound, not light, and they show us the broad shape of the seafloor, its depth, its contours, its general geography. But they do not show us what is happening there. They do not show us the life, the chemistry, the processes, the slow and continuous activity that characterizes the ocean floor in all of its diversity. To see those things, you have to go there. And going there, as the history of the Mariana Trench makes clear, is difficult, expensive, and slow. It requires machines that can withstand pressures that most materials cannot. It requires patience. It requires a willingness to spend years or decades building up a picture one small observation at a time. And even with all of that, the coverage remains thin. This is not a failure of science or of human curiosity. It is a consequence of the nature of the environment itself. The deep ocean does not yield its secrets easily or quickly, and the tools we have for exploring it are limited by the same physics that shape the environment, by pressure, by darkness, by cold, by the sheer distance between the surface and the floor. We have, in a sense, explored the deep ocean the way an archaeologist explores a buried city, carefully, slowly, one small patch at a time, assembling a picture from fragments, and always aware that the picture is incomplete, and that the fragments we have found are only a fraction of what is there to be found. The Mariana Trench, in this context, is not the end of something. It is not the final frontier in the way that phrase is sometimes used, as though the deepest point were the last unknown, the final piece of a puzzle that is otherwise complete. It is, rather, a reminder that the puzzle is far from complete, and that the deepest point is simply the most dramatic illustration of how much of it remains unfinished. The ocean floor, in its entirety, is a landscape that human beings have barely begun to walk. The Mariana Trench is the place where that fact is most visible, most undeniable, most impossible to explain away or minimize. But it is not the only place where it is true. There is something humbling in this if you allow yourself to sit with it, not the humbling that comes from feeling small or ignorant or inadequate, but the humbling that comes from realizing that the world you live on is larger and stranger and more complex than you had assumed, and that the assumption of completeness, the feeling that you know more or less what the Earth is and what it contains, was always, in some quiet way, premature. The ocean covers more than 70% of this planet. It is the dominant feature of the world, the thing that makes it blue when seen from space, the thing that shapes its climate and its chemistry and its capacity to sustain life. And most of it, in the deepest and most fundamental sense, remains unknown, not as a mystery to be solved, as a place to be visited, slowly over time with patience and care, and a willingness to accept that understanding will come, if it comes at all, on its own terms. The Mariana Trench is simply where that truth is deepest, where the distance between what we know and what is actually there is at its greatest, and where the silence between the two has the most room to breathe. There is a particular kind of discomfort that arises when we encounter something we cannot fully understand. It is not the discomfort of pain or of fear or of any physical sensation. It is quieter than that. It is the feeling that something is missing, that there is a piece of information we do not have, a gap in the picture, a question that has been asked but not answered, and that the not answering is somehow incomplete, somehow unsatisfying, as though the world owes us resolution and has failed to provide it. This discomfort is so familiar, so deeply woven into the way we relate to knowledge, that we rarely notice it as a feeling at all. We simply notice the gap and we orient ourselves toward filling it, and the filling becomes a project, a goal, something to work toward, because the alternative, sitting with the gap, accepting it, allowing it to remain, feels to most of us like giving up. The Mariana Trench does not invite resolution. It does not offer the kind of satisfying conclusion that most stories about the natural world eventually provide. It does not yield, after enough effort or enough time or enough technology, a complete and coherent picture of what it is and what it contains and how it works. It yields pieces, fragments, observations that are real and meaningful, but that do not add up, yet to a whole. And the gaps between those pieces, the spaces where our knowledge ends and the trench simply continues, unobserved and unrecorded, are not shrinking quickly. They are shrinking slowly, if at all, because the pace at which we can learn about the deep ocean is determined not by our curiosity or our ambition, but by the place itself, and the place has no interest in being understood on any timeline but its own. This is, for many people, an uncomfortable position to be in. We are accustomed to the idea that knowledge progresses, that with enough time, enough effort, enough ingenuity, the unknown becomes known, and the gaps close, and the picture fills in. And this is true in many areas of human inquiry. It is true of medicine, and of physics, and of the history of the earth, and of countless other fields in which patient and sustained investigation has, over decades or centuries, transformed deep ignorance into deep understanding. But the deep ocean is a place where this progression is extraordinarily slow, and where the remaining unknowns are not the kind that can be resolved by thinking harder or building better instruments. They are the kind that can only be resolved by going there, and going there, as we have seen, is a slow and limited process, and will remain so for a very long time. What happens when you sit with this, when you allow the incompleteness of our knowledge about the Mariana Trench to be not a temporary condition, but a likely permanent one, or at least a condition that will persist for far longer than any individual human life, is that the discomfort begins gradually to dissolve. It dissolves not because it is replaced by understanding, but because it is replaced by something else, a quieter and more patient relationship to the unknown, one in which the not knowing is no longer felt as a lack, but as a presence. The unknown becomes, in this way, not an absence but a space that has its own character, its own texture, its own kind of meaning, and that does not need to be filled in order to be valued. The Mariana Trench has been unknown in this sense for as long as human beings have been aware of its existence. It was unknown to the sailors who first crossed the Pacific and did not know what lay beneath them. It was unknown to the scientists who first began to measure the depth of the ocean floor and found numbers that were larger than anything they had expected. It was unknown to the engineers who built the first submersibles and sent them downward, and it was unknown to the men who rowed those submersibles to the bottom and looked out through their small windows at a darkness that told them almost nothing about what was there. And it is unknown now in many of the same ways and in some new ones, and the unknowing has not diminished the place. It has not made it less real or less significant or less worthy of attention. It has simply meant that the place exists in a way that is larger than our understanding of it, and that this largeness is not a problem to be solved, but a condition to be acknowledged. There is a word for this in certain philosophical traditions, a word for the acceptance of uncertainty as something other than a failure, as something that can coexist with knowledge without undermining it, as something that can even enrich it by keeping it honest, by preventing it from becoming too comfortable, too closed, too convinced of its own completeness. The word varies depending on the tradition, but the idea is the same across many of them, that not knowing is not always something to move away from. Sometimes it is something to move toward. Sometimes it is the more interesting and the more truthful place to be. The Mariana Trench is one of the places on Earth where this idea feels most natural. It is a place that has been from the beginning larger than our capacity to understand it, and that has continued to be larger, quietly and patiently, while we have tried, in our slow and limited way, to learn what we can. The unknowing is not a failure of the trench. It is not a failure of science. It is simply a reflection of the relationship between a place that is vast and slow and ancient, and a species that is small and fast and young, and that has only just begun to turn its attention downward, toward the depths, and to listen for what the depths might say, if given enough time and enough silence and enough willingness to hear. The trench will not change to accommodate us. It will not speed up its revelations, or simplify its complexity, or arrange itself into a narrative that we can follow easily from beginning to end. It will simply continue, as it has always continued. In the dark, in the cold, in the pressure, in the silence, and the unknown will remain a part of it, not as something waiting to be discovered, but as something that belongs there, as naturally and as permanently as the water itself, and that will continue to belong there long after we have stopped asking about it. And when the asking stops, or when it quiets the way all things quiet eventually, what remains is simply the place itself, and the stillness of it, and the long, unbroken continuity of a silence that has nothing to prove, and nowhere to go, and no reason whatsoever to change. There is a place beneath 11 kilometers of water where the darkness has no edge, and the silence has no source, and the weight of the world presses down with a patience that has no name. It has been there in more or less the same way, for longer than most things on this planet have existed. It will continue to be there, in more or less the same way, for longer than most things on this planet will continue to exist. And in between, in the narrow, brief window of time in which human beings have become aware of it, have turned their attention toward it, have sent their slow and careful machines downward to look, it has not changed. It has not hurried. It has not opened itself to understanding the way a book opens, or a door opens, or a question opens, when someone is willing to answer it. It has simply remained. There is something restful in that. Not restful the way a holiday is restful, or a quiet evening is restful. Those are rests that exist in contrast to activity, pauses between one thing and the next. This is a different kind of rest. It is the rest of something that has never been disturbed. The rest of a place that does not know it is resting, because rest for it is not a state but a nature. The sediment at the bottom of Challenger Deep has been settling for thousands of years, one thin layer at a time, and each layer is indistinguishable from the one before it. And the settling will continue long after the last layer we could ever measure has been laid down. There is no beginning to it that we can point to. There is no end. We came here, in this telling, because of a question. Not a question that needed an answer exactly, a question that needed to be sat with, the kind of question that does not resolve so much as it deepens, that opens slowly into a larger and quieter space than the one it started in, and that leaves you, at the end of it, not with more knowledge than you had before, but with a different relationship to the knowledge you already possessed. The Mariana Trench did not teach us anything, in the way that a lesson teaches. It simply held its space and let us look, and let us wonder, and let the wondering be enough. There are fewer human beings who have seen the bottom of that place than have walked on the moon. This fact has not changed. It will not change quickly. The bottom will continue to be visited rarely, if at all, and the water above it will continue to press down with the same force it has always pressed down with, and the creatures that live there will continue to live there in the dark and the cold and the quiet, going about the slow business of existing in a way that does not require an audience. They do not know we have been thinking about them. The place does not know we have been thinking about it. And there is a freedom in that, in the idea that something so vast and so old and so complete can exist entirely independently of whether anyone understands it or cares about it, or stays awake at night wondering what it is like to be at the very bottom of the world. The depth is still there, the darkness is still there. The silence that is not an absence but a fullness, the silence of a place in which everything is happening exactly as it has always happened, in a register we cannot hear, is still there. None of it has changed because we spent time with it. None of it will change because we leave. It will simply continue, the way it has always continued, in the same cold and the same dark and the same slow and patient pressure, and the seafloor will continue to accumulate its thin layers of sediment, and the amphipods will continue to move across it, and the water will continue to press down, and the trench will continue to deepen by fractions of millimeters over spans of time that have no meaning in any human frame of reference. And if you sit with that, if you let it settle the way the sediment settles slowly without resistance, what you find is not emptiness, It is not the emptiness of a place with nothing in it. It is the fullness of a place that has everything it needs, and has had everything it needs for a very long time, and that asks nothing of us except, perhaps, that we notice it, that we turn our attention, briefly, downward, that we remember for a little while that beneath the surface of the world we walk on, there is another world entirely, one that is quieter than anything we have ever known, and older than anything we have ever touched, and stranger than anything we have yet imagined, and that it is enough simply to know it is there. If this journey brought you a sense of calm, you can subscribe to Quiet Science and continue exploring these silent depths with us.